Namaskaram. Welcome to Mana TV Telangana. In the last session, we have discussed on coordinate geometry and also we have covered some of the formulae related to the coordinate geometry. So today, we shall discuss some more points. After that, we shall have a clear discussion on problems. So first, let me repeat the concept of once again inclination of a line. So what is the inclination of a line? A line which subtends an angle with x-axis in anti-clockwise direction is called inclination of a line. It is denoted by theta. And also we have discussed a range of inclination, that is theta. The range of theta is, it lies in between 0 and 180 degrees and it may be equal to 0 but not equal to 180. So that means actually here we get 0 degrees less than or equal to theta, theta less than 180 degrees. So that means always the theta lies in first quadrant and second quadrant itself only. So that in the previous session we have discussed. So now, let us discuss what is the slope of a line. What is meant by a slope of a line? The slope of a line is defined as the tangent of inclination. So tangent of inclination means, suppose if theta is the inclination of a line, then the tan theta is the slope of a line. Sometimes slope of a line may be termed as gradient of a line also. So it is denoted by a letter m. So hereafter m is equal to tan theta. So today let us concentrate on slope of a line and after that we study more points on coordinate geometry also. So slope of a line. Slope of a line. Slope of a line. Let theta be the inclination of a line, then tan theta, that means tangent of theta, tan theta, shortly we write it as tan theta, is called as the slope of the line or slope of a line. Denoted by m. Hereafter in this chapter m is equal to tan theta. So it doesn't have any units because it's a trigonometric ratio, so we don't have any units. So m is a constant value, m is equal to tan theta. Okay. Now how to find out slope of a line joining the points x1 comma y1 and x2 comma y2. Otherwise, when 2 points on a line is given, how to calculate its slope or how to find out slope of a line when 2 points on a line is given. So now suppose this is a line, say L, let 2 points say A, B, A is x1 comma y1, B is x2 comma y2. Then how to find out slope of this line L? So as A coordinates are given and B coordinates get given. Now the slope is given by m is equal to difference of y coordinates by difference of x coordinates taken in order, taken in order. So that means y2 minus y1 by x2 minus x1, or we can write y1 minus y2 is equal by x1 minus x2. Here where in both cases x1 does not equal to x2, x1 does not equal to x2. So slope of the line, of a line passing through x1 comma y1 and x2 comma y2 is given by y2 minus y1 by x2 minus x1, or y1 minus y2 by x1 minus x2. So with the help of slope concept also we can prove the given 3 points are collinear. How to prove the given 3 points are collinear? With the help of slope concept. See, for example, if A, B, C are given points, or given points, suppose slope of AB equals to slope of BC equal to slope of CA or AC, then ABC are collinear. ABC are collinear. If ABC are collinear, then slope of AB is equal to slope of BC or slope of CA also we shall consider. So while doing the problems, so we can apply this concept also. Now let us have a discussion on centers of a triangle. The first, before going to the discuss centers of a triangle, first let us concentrate on what is the median of a triangle, and what is the altitude, and what is the perpendicular bisector of a side, what is the angular bisector. So let us discuss these four concepts first. See, first take a triangle, say ABC, okay, this is A, B, C, vertices of a triangle ABC. Let D be the midpoint of BC, just you join it. Now this AD is called median, AD is called median, drawn from the vertex A to the opposite side BC. Okay, now take one more triangle, same ABC only you consider, ABC, draw the perpendicular from A to the opposite side BC. So draw the perpendicular, say AD. As AD is perpendicular to BC, here AD is called in this case altitude, altitude. So now you take again triangle ABC, A, BC. Now divide this angle into equal parts. So this is, now this AD is called internal angular bisector of A. So AD is angular bisector, and which is internal angular bisector. In the similar pattern, so we can find out external angular bisectors also. So that we will discuss later. So let us come to the first center, that is centroid. Okay. Suppose you take a triangle ABC. Let D be the midpoint of BC. Now join AD. What do you get it? AD is the median. Now consider E be the midpoint of CA. Now join BE. Similarly, let us consider F be the midpoint of AB. Join CF. Now let us have one question. How many medians can be drawn for the triangle ABC or for any triangle ABC? It's clear that 3 medians can be drawn. One is AD, BE, CF, which refers to triangle ABC. Just if you observe, these 3 medians meet at one point. If 3 or more points meet at one point, they said to be concurrent lines. So that means it is clear that these 3 medians are concurrent. Am I correct? The point of concurrence of the medians is called centroid. That is denoted by capital G. Sometimes we may call it as center of gravity also, or center of mass also. So that means now this is capital G. Now let us write it. The point of, or we can say like this, here medians of a triangle are concurrent. It's clear, concurrent. The point of concurrence of medians of a triangle is called centroid. Denoted by capital G. Okay. Now suppose here A coordinates are x1 comma y1, B coordinates are x2 y2, and C coordinates are x3 comma y3. Now let us find out the coordinates of the centroid G. The coordinates of the centroid G are given by here formula we have G is equal to x1 plus x2 plus x3 by 3, next y1 plus y2 plus y3 by 3. That means mean of the x coordinates of the vertices and mean of the y coordinates of the vertices. That means suppose if the 3 vertices of the triangle are given, it is very simple to find out the coordinates of the centroid is given by mean of the x coordinates comma mean of the y coordinates, that is x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Even this can be written shortly also like this, sigma x1 by xi by 3 comma sigma yi by 3, where I is equal to 1 to 3. You can remember like this also. Okay. Generally, what sort of questions may appear in different competitive entrance examination based on the concept of the centroid? So that means regarding to the centroid, if the two of the vertices of the triangle will be given and centroid will be given, and we are asked to determine or we are asked to find out the third vertex. So let us have a discussion on that one, because that is very important problem that may appear in the examination. So that means here that is also known as missing vertex. Say A x1 comma y1, B x2 comma y2, C is not given. Suppose here centroid is given, say that is x comma y. Now how to find out the centroid of here third vertex of triangle ABC? As A, B, two vertices are given, centroid is given. Now we have to find out the missing vertex, that is the third vertex we have to find out. Now I will give one easy shortcut formula for this one. See, simply you do one thing, add x1 and x2, subtract from x, you get x coordinate of C. If you want to find out y coordinate of C, add y1 and y2, get it to be subtracted from y. So we can remember the C coordinate as like this, third vertex that is C is equal to, I already told you, x minus of x1 minus x2, or 3 times, sorry, 3 times here you have to write. Next, this is 3 times of y minus y1 minus y2. You remember like this. So now let us have orthocenter. So let us have a discussion on orthocenter. Before going to discuss orthocenter, so we need a concept of altitude. After that, so easily we can have the concept of orthocenter. So now take the triangle ABC. Say this is x1 comma y1, this is x2 comma y2, this is x3 comma y3. Let draw a perpendicular from A to opposite side BC, say AD, D be the known as foot of the perpendicular on BC. Now draw the perpendicular to the opposite side. E is the foot of the perpendicular on AC from B. Now similarly, you drop the perpendicular from C to the opposite side AB. Say this is F. D, E, F are known as feet of perpendiculars. Feet of perpendiculars. D, E, F are called feet of the perpendiculars. Now, just if you observe, AD is the median, BE is the median, CF is another median. These three meet at one point, that is called point of concurrence of the altitudes. The point of concurrence of the altitudes is known as orthocenter. This is generally H or O, no problem, denoted by, so better you remember as a H. So now altitudes of a triangle are concurrent. The point of concurrence of the altitudes of a triangle is called orthocenter. Denoted by H, or in some textbooks it may be O also, H or O. So now centroid is denoted by G, whereas orthocenter is denoted by H or O. Okay. Some observations on orthocenter. First observation. What is the first observation means? Suppose, just observe this triangle. So what kind of triangle is it? Yes, it is acute angled triangle. So it is an acute angled triangle. In acute angled triangle, always orthocenter lies inside of it. So that means orthocenter H lies inside. So this is the observation. Suppose you consider other triangle. Say ABC. So this angle. So what kind of triangle this is? Yes, it is obtuse angle triangle. This is acute. This will be obtuse angle triangle. Obtuse angled triangle. Since it is obtuse angle triangle, the orthocenter lies outside. That means H lies outside. Okay. Now, one more triangle you take consider, that is this type of triangle. You might have expected what kind of triangle this is. This absolutely right angle triangle. Since it is a right angle triangle, so very interesting. If it is the right angle triangle, always in a right angle triangle, the vertex which is opposite to the hypotenuse is nothing but orthocenter. So that means in this triangle, see, this B is opposite to the hypotenuse, greatest side. So that's why this B is known as the here orthocenter. So that means in this case H is the vertex opposite to its hypotenuse. So these are the observations we can have. Okay. So one more observation. Let H be the orthocenter of the triangle ABC. Okay. Let H be the orthocenter of the triangle ABC. Now AD, BE, CF, altitudes, this is H. So very interesting. Suppose orthocenter and vertex A, vertex B, two vertices and orthocenter is given. Now how to find out the missing third vertex? See here one logic is there. Suppose A, B, H are given, we are asked to find out the missing vertex, that is third vertex we have to find out. So in order to find out third vertex, it is very simple. Third vertex is the orthocenter of ABH triangle. Similarly, suppose here C is the orthocenter of triangle ABH, B is the orthocenter of triangle ACH, A is the orthocenter of triangle BCH. Okay? Let us write it now. A is equal to orthocenter of triangle BCH. B is equal to orthocenter of triangle ACH. In the similar manner, C is the orthocenter of triangle ABH. Okay, you might have observed very clearly this one. Okay, now So we shall have one question. In competitive entrance examination, how do we actually appear this question? So this question may be given like this. A vertex, B vertex and C vertex will be supplied, and we are asked to find out its orthocenter. So you need not worry about that one. We have one shortcut formula. Okay, let us recall that shortcut formula step by step. Stepwise, how can we actually solve that problem by using tips and tricks itself only. Okay. Suppose triangle ABC is given, let A coordinates are x1 comma y1, say B coordinates x2 comma y2, C coordinates are x3 comma y3. So let A, B, C coordinates we have actually determined here. So first, in order to find out orthocenter, first step 1 you do it. Follow this step. What is the first step means? Find K value, where K is equal to x1 into x2 plus y1 into y2 by x1 y2 minus x2 y1. Always you remember. In the step 1, first we have to find out the value of K, where K is given by this formula x1 x2 plus y1 y2 divided by x1 y2 minus x2 y1. In the step 2, directly we get orthocenter. H is equal to K times y2 minus y1 into K times x1 minus x2. But here one thing you remember, this one of the vertices must be here, this x3 y3 is origin. That means if one of the vertices must be origin 0, 0, then we can follow like this. Suppose if one of the vertices may not be 0, 0 also, we can find out. That I will explain during the problem sessions. Okay. Next, circumcenter. Circumcenter. Now, ABC, let us consider triangle ABC. Let this is the perpendicular bisector of BC. So let this is the perpendicular bisector of CA. This is the perpendicular bisector of AC. They meet at one point. See, this is known as circumcenter S. What do you observe in this one? The perpendicular bisector of the sides of the triangle meet at one point. So, the point of concurrence of the perpendicular bisectors of the sides of a triangle is called circumcenter. or otherwise it may be defined like this. So, actually the center of the circle which is passing through the three vertices of the triangle is also known as circumcenter. So, that may be defined like this. For example, you take a circle like this. So, inscribe a triangle like this, suppose. Say this is A, this is B. That means we have drawn a circle through the vertices of the triangle ABC. Then the center of this circle, yes, for example, this is known as the circumcenter of triangle ABC. Both ways we can define. From this we get one very important concept that may be applied for while writing the examination. Suppose you join this SA, join SB, join SC. What do you observe? This SA is known as distance from center to the point on the circle. This circle is also known as circumcircle. So, this is called circumradius, this is called circumradius, this is called circumradius. So, that means here we get SA is equal to SB is equal to SC. That means circumcenter is at a distance of equidistant from the three vertices of the triangle. The point which is equidistant from the three vertices of a triangle is nothing but circumcenter. Understood now? If S is the circumcenter, then SA is equal to SB equal to SC. So, now let us write it now. Okay, this is additional information. So, now perpendicular bisectors of the sides of a triangle are concurrent. Okay, am I correct? The point of concurrence of the perpendicular bisectors of the sides of a triangle is called circumcenter. Denoted by S. Okay. Okay, now let us have some more observations on circumcenter. Take a acute angle triangle, say ABC. So here S lies inside, just like orthocenter itself only. Suppose if you consider obtuse angle triangle, say A, B, C. In this case, S lies outside. Suppose if you consider right angle triangle, this is very, very important. Say ABC, this is a right angle triangle. In right angle triangle, the midpoint of the hypotenuse, this is the circumcenter. So that means here S is equal to midpoint of AC. So that is the hypotenuse. If it is a right angle triangle, since it is a right angle triangle. Okay, let us go for other concept. See, let us draw a circle. Let us inscribe a triangle in it. So let the triangle be inscribed in the circle. Say ABC. We know this is the circumcenter. You join SA, SB and SC. So this is hereafter SA is equal to SB is equal to SC, say that is R, where capital R is known as circumradius. So now here R is called circumradius. And also here let us assume BC is equal to small a, as opposite to vertex A we can say small a. Now CA is equal to B and AB is equal to small c. With the help of actually small a, small b, small c, they are called actually elements of the triangle ABC. We can find out area of the triangle ABC, or even we can determine circumradius also. So that means here circumradius is given by the formula R is equal to ABC by 4 delta, where delta is the area of triangle ABC in this case, or area of the triangle. As capital R is equal to ABC by 4 delta, what is delta? Yes, delta is equal to ABC by 4R. Okay. Now let us discuss one more center, that is in center. Okay, in center. Now consider a triangle ABC. consider angular bisector of A, that is say AD, which meets BC at D, and next other angular bisector, this is another angular bisector, say CF. These two are equal, these two are equal, these two angles are equal. So now they meet at one point. This is known as in-center, denoted by I. Now what is meant by the in-center here now? Here in-center is the point of concurrence of the internal angular bisectors of the triangle. So that means the point of concurrence of the internal angular bisectors of a triangle is called in-center. In-center denoted by I, capital I. Okay. See, for your better understanding, so let me repeat once again. The point of the concurrence of the internal angular bisectors of a triangle is called in-center, denoted by the I. So in another way also we shall define in-center. See, so consider a circle. So otherwise, first consider a triangle. This time inscribe a circle. So let the circle is be inscribed in the triangle. Okay. Now say A, B, C. Here so this is known as I. If a circle is inscribed in a triangle, the center of this circle is known as in-center. This circle is named as in-circle. Okay. So now here we get one important thing. This is, suppose say D, E, F. Here ID is equal to IE is equal to IF. We get one of the important observation. What is the important observation? The point which is equidistant from the sides of a triangle is nothing but in-center. That means in-center is equidistant from the sides. But whereas circumcenter is the equidistant from the vertices. So that is the difference between circumcenter and in-center. So how do you differentiate circumcenter and in-center? So in-center is equidistant from the sides of the triangle, whereas circumcenter is the equidistant from the vertices. Okay, understood now. So in this case now, the radius of in-circle is denoted by small r. that is called in radius. In radius is denoted by small r. Capital R is circumradius, whereas small r is in radius. Now, how to calculate small r? Let us have a discussion. So, if you want to find out small r, we require perimeter of the triangle and also area of the triangle. So, area of the triangle can be calculated using Hero's formula, or if right angle triangle is there, easily we can find out. Even if it is equilateral triangle, easily we can find out with the help of root 3 by 4 a square. So, better you can follow Hero formula itself only. So, that is delta, for example. Then the in radius is calculated with the help of r is equal to delta by s, here where s is equal to semi perimeter, that is a plus b plus c by 2. Okay, now three vertices are given, say A, B, C. How to find out its in center? That means coordinates of in center. A x1 comma y1, B x2 comma y2, C x3 comma y3. Suppose here say BC is A, AC is B, AB is C. Now, in center is given by the formula in center I is equal to, given by the formula AX1 plus BX2 plus CX3 by A plus B plus C. Okay. Next, AY1 plus BY2 plus CY3 by A plus B plus C. Okay. Now, if you want to find out in center of the triangle, whose the vertices of the triangle are given, first we have to find out A. A means BC, the distance from B to C we have to calculate. Next, B we have to calculate, that is CA. C we have to calculate. Having been evaluated or calculated the values of ABC, then using this formula we can find out in center of the triangle. So, my dear friends, so far we have discussed here centers of the triangle, that is centroid, orthocenter, circumcenter, and next in center in detail. So, in the next classes we shall discuss problems on them. So, thank you for watching. Thank you one and all.